Hi, my name is Courtney Mackay, and today I'm going to walk you through this quick demo of Amazon SageMaker Feature Store. We'll walk through the capabilities of SageMaker Feature Store and how Feature Store can be used in your machine learning workflow. So what is SageMaker Feature Store? We'll start by talking about what is feature engineering and why it is important and challenging. In machine learning, features are the foundation of a high-quality model. Data scientists and developers can easily spend 60% of their time designing and creating features. And this process often requires a few iterations until a model reaches a target level of accuracy. The challenges go beyond writing and testing your feature engineering code. First, features built by different teams or during different time frames are not consistent, introducing variations that can impact model results. Second, extensive and repetitive feature engineering work is often needed when productionizing new features. And last, it can be difficult to track feature versions, and up-to-date features are often not easily accessible. Team members are at risk of duplicating feature engineering code because they have no awareness of or ability to access previously created features. To address these challenges, SageMaker Feature Store provides a fully managed central repository for creating, sharing, and retrieving machine learning features for training and inference with low latency. Features stored in SageMaker Feature Store are organized in groups and tagged with metadata, making it easy to securely store and retrieve features without the heavy lifting of managing the infrastructure. Using SageMaker Feature Store, you can quickly discover available features and determine if they would be useful for your models. Multiple teams can access a feature store, enabling sharing and reuse of features across teams. In this demo, we will be working in SageMaker Studio, which is a fully integrated development environment for machine learning, providing complete access, control, and visibility into each machine learning development step, all in one place. In order to follow along with this demo, you will need to clone the example notebook to your own SageMaker Studio notebook instance. Once you are in SageMaker Studio, you can go ahead and click on the Git tab and clone the repository. I already have the notebook cloned in my folder, so I'll go ahead and open the Feature Store demo notebook. This Python code can be run entirely, or you can run the notebook cell by cell. We'll walk through a pre-run version of the notebook so that we can see all of the outputs at once. Before starting to go through the notebook, we'll make sure that we have the correct policies attached to the execution role that you use to create your SageMaker Studio instance. We will need the following 3 policies: SageMaker Full Access, SageMaker Feature Store Access, and S3 Full Access. Now let's first find and copy the role name you used to create the Studio instance. You can find your execution role by going to the SageMaker console, opening Amazon Studio by either clicking in the left window or using the right button, and under Studio Summary, you will find the execution role name. Copy the role name, and then we'll navigate to the IAM console to make sure that we have the correct policies attached. Using the search bar at the top of the screen, search for IAM, click on IAM, and it will take us to the IAM console. Choosing Roles in the left navigation pane, we can search for the execution role that we just copied from the Studio Summary. Choose the role name, and it will bring us to the detail page for this role. Under Permissions, we can review the permissions currently attached to the execution rule to check if the 3 required policies are listed. If you are missing any of the required policies, you can choose Attach Policies, and use the search bar to find the policies that you're missing from the list and attach these necessary policies. Great! Now we have everything we need to run through the notebook. Our example uses a clinical dataset that we'll use to predict patients' risk of heart failure. But you can easily switch data sources to fit your preferred use case. The dataset is a public dataset and can be accessed at the UCI Machine Learning Repository, as linked in the notebook. The dataset contains medical record information for heart failure patients, including demographic, diagnostic, and laboratory test data. In this notebook, we'll first introduce the terminology and components of FeatureStore, then we'll examine our data and prepare the data for FeatureStore. Once the data is ready, we will create the features, go through a few examples on how you can work with the features, and lastly, build a model to show how you can retrieve a feature value from the FeatureStore and invoke the machine learning model to return a prediction. To help with context, we will start by familiarizing ourselves with a few terms. A feature group is the main FeatureStore resource that contains the metadata for all the data stored in SageMaker FeatureStore. A feature group is a grouping of features to describe records. You will define it in the FeatureStore, and a feature group's definition is composed of a list of feature definitions, a record identifier name, and configurations for its online and offline store. Now we just mentioned 4 new terms here, and we'll explain them one by one. A feature definition consists of a feature name and one of the following data types: an integral, string, or fractional. With a name and data type, this is like a schema for a database table, if you're familiar with databases. A record identifier should be a unique ID to identify each instance of the data. For example, primary key, customer ID, transaction ID, and so on. The record identifier name must refer to the name of the unique ID column. Now the offline store stores historical data in your S3 bucket. It is used when low latency reads are not needed. For example, when you want to store and serve features for exploration and model training. In this demo, we will use offline stores to build our training data for modeling. Now, an online store is the low latency, high availability cache for a feature group that enables real-time lookup of records. You can easily access the online store for the latest value of a record. In our demo, we'll use the online store to get the record for a patient in our test set and then trigger the model for inference. In our demo, we will use the online store to get the record for a patient in our test set. We'll then trigger the model for inference. Lastly, we have event time. This is a point in time when a new event occurs or an update of a record happens in a feature group. All records in the feature group must have a corresponding event time. This can be used to track changes to a record over time. The online store contains a record corresponding to the last event time for a record identifier name, whereas the offline store contains all historic records. To tie everything together, the following diagram illustrates the flow. After data is processed, it will be ingested into the feature store we created. Then portions of the data will be used as a training set to train a quick model. The model will be deployed for future use. The left-out data will be used as the test data, and we'll use it to trigger the deployed model to make a prediction. Now let's start developing. The setup is pretty standard. We'll set up the SageMaker Python SDK and Boto client, an S3 bucket for the offline store, and the execution role. As we mentioned before, the dataset we're going to use in this demo is a clinical records data to predict heart failure. It contains electronic medical records of 299 patients, and out of 13 columns, 12 columns can be used as features directly. The data includes information such as age of the patient, whether or not the patient has diabetes, and information on the patient's laboratory results, such as reported levels of serum sodium in the blood, and so on. The target column is the death event column, where 1 means the patient has heart failure. Our model is going to predict the patient's survival from the clinical records. To clarify, the time column here is not the event time column we just mentioned when reviewing feature store definitions. In the dataset, the time column is the follow-up period or the duration of time between when the patient was last seen and either death or the end of the study period. We will create the feature store event time column later in the demo. So we'll download the data from the online source, upload it to our S3 bucket under the data folder, and check if any pre-processing is required. In this case, the dataset contains no missing values, and all columns are either numerical or binary. Therefore, no processing or feature engineering is needed in our case. We'll just use all of the features as they are. But depending on your data and your use case, you should examine the data and decide if there's any pre-processing or feature engineering steps needed before you ingest your data into Feature Store. Now, let's get our data ready for Feature Store. Take a look at the data types and make sure they're all correct and readable by Feature Store. As we mentioned when we went over the terminology, specific features will be flagged as a record identifier and event time, and a combination of record identifier name and a timestamp uniquely identifies a record within a feature group. We'll need to specify a record identifier and event time in this case, since the raw data does not contain the 2 columns, so we'll need to create them. We're going to create a unique ID for each patient as a record identifier column. And then we'll create an event timestamp for each record as the event time column. Lastly, we'll make sure to check the data types for each column and convert any object type to string type so that the SageMaker Feature Store Python SDK can map the string data type to string feature type. Float will be mapped to fractional, and int will be mapped to integral. Now that our data has all of the necessary components, we will create a feature group. When you set up your feature groups, you need to customize the feature group with a unique name. In this case, we will call the feature group Clinical Feature Group, and add the current timestamp to it to make it unique. Then we'll set up the feature group with the feature group class by passing in the name and the session. Next, we will need to define the record identifier name and event time name. We created these 2 columns in the last step, which is the patient ID and event time. We can now load the feature definitions by passing the clinical data frame that contains the feature data. SageMaker Feature Store Python SDK will auto-detect the data schema based on the input data. You can also follow the step-by-step guide linked in the notebook to use a schema instead of automatic detection. In this step, we will use the create function to create the feature group. Note that the online store is not created by default, so you must set this as true if you want to enable it. The S3 URI is the S3 location of your offline store. You can also define KMS IDs for offline and online stores separately and encrypt all of your data. In the case that you do not provide a CMK, Then we ensure that your data is encrypted on the server side using an AWS-owned CMK or an AWS-managed CMK. Another parameter that you can define are tags. You can define tags to help you search for and manage feature groups, such as whether this feature group is for a dev or prod environment, or which cost center the feature group should be associated with. It will only take us a few seconds to create this feature group. Once created, let's explore what you can do with the feature group. First, you can retrieve information about your feature group with the describe function, or list all of your feature groups with the list feature groups function. After the feature groups have been created, you can put data into the feature groups by using the put record API. You can use the ingest function to load your feature data. You pass in a data frame of feature data, set the number of workers, and choose to wait for it to return or not. For this example, to accelerate the ingestion process, we are specifying multiple workers to do the job simultaneously. It will take less than 1 minute to ingest data to the clinical feature group we created. You can use the getRecord function to retrieve the data for a specific record by its record identifier. In this demo, we'll use this function to get feature values for one test patient later. Additionally, you can generate Hive DDL commands. The schema of the table is generated based on the feature definitions. Columns are named after the feature name, and data type are inferred based on the feature type. Lastly, let's wait for the data to appear in our offline store. This will take approximately 5 minutes. We will use the data stored in the offline store to create a training set for our next step, modeling. Since SageMaker Feature Store automatically builds an AWS Glue data catalog when we created the feature groups, we are going to utilize this auto-built catalog to build our training set. We run an Athena query that does a simple select from the table and limit 290 random samples in the offline store in S3 from the feature group. For testing purposes, we left out 9 records when creating the training dataset, so that we can use the left out 9 records as test data for the reference. You could also do a train test split here. We'll make a note of the patient IDs left out for testing to retrieve the feature values by the patient ID later on. Next, we get the data ready for training by keeping only the feature columns and putting the target variable in the first column. We will also need to upload the data to S3 since we're going to create a SageMaker training job, and SageMaker training jobs read from S3 by default. Now, let's train and deploy a quick model for Inference. For model training, we will use a SageMaker built-in algorithm called XGBoost to predict if a patient is likely to have heart failure. SageMaker built-in algorithms provide highly optimized implementations of popular machine learning algorithms, simplifying the machine learning development and accelerating training and deployment. We will call the SageMaker XGBoost container and construct a generic SageMaker estimator. In this example, we'll skip hyperparameter tuning and go with the default hyperparameters, as our goal is not necessarily to achieve the best model in this case, but to demonstrate feature store capabilities. We train the model for 50 rounds and deploy the model as a SageMaker real-time hosted endpoint, which we will call later to generate predictions. This will take about 8 to 10 minutes to complete. Once the model endpoint is ready, we select a patient ID from our withheld test dataset and query our online feature group to build our inference request. From the patient ID we left out in the training set, we can choose one patient ID to test the real-time inference. In this example, we choose patient 287, but you can choose either one from the left-out ID list for testing. To get the feature value for a patient in the test set from our online feature store, using this patient's ID, we can use the getRecord function. Then we choose the feature value from the retrieved feature list, exclude the record identifier ID, the event time, and the target variable, and build a list of values as the input to the predictor. The predictor will call our hosted model and give a prediction result. In this case, it seems like the model predicted the patient 287 is very unlikely, with a 0.2% chance, to die during the follow-up period. Comparing to the original test data before we excluded the target variable, where the death event is 0, the model made the correct prediction. Finally, once we are done with our model, we have the option of deleting our endpoint as well as the feature group that we created. And there you have it. We've explored SageMaker Feature Store by walking through a demo for heart failure detection using clinical data. There are some additional resources and extensions of the demo at the end of the notebook. You can check the launch blog for a guide on how to use Feature Store with SageMaker Studio Console, or follow another blog that combines streaming feature ingestion using Amazon Kinesis and batch feature ingestion from a SageMaker Spark container. There is an additional example Feature Store notebook using credit card fraud detection data. All of these resources are linked at the end of the notebook.